Okay, so um, today in advanced algebra triggers 1.8 rational exponents. There was 3 boxes. The first thing we talked about was these two rules here. These two rules of a to the 1 over n is the same thing as the nth root of a to the first, and then a to the m over n is the nth root of a to the m. So we're going to practice with those today. So I have a couple of examples here. So the first one is 4 to the 3/2 power. That can be rewritten as, I'll use red here so you guys see it. This can be rewritten as the square root of 4 all to the third, which of course is just 2 all to the third, which is 8. So this one has a value of 8. Now remember, when we have a square root out here, you don't actually have to write the 2, but it is still there. It's implied when you take a square root. Number 2, we have, this is the cube root of -8 all to the 4th power. Now the cube root of -8 is just -2 to the 4th power is 16. Number 3, since we have a negative exponent, we take the reciprocal first, 1 over 32 to the positive 2/5 power, which is just 1 over the 5th root of 32 all squared, which is 1 over the 5th root of 32 is 2, so 2 squared, so the answer is 1/4. And then number 6, I put this one in specifically to remind you that you can simplify a fraction in the exponent first to give you an answer of 4 to the 3/2, which is exactly the same problem as number 1. So you are allowed to do that. Then we went on and started working with radicals. And we had an example number 5 where we have the 9th root of x to the third. That's the same thing as x to the 3/9, which is x to the 1/3, which is just the cube root of x. So you can simplify that. And number 6, there's a star by number 6 because it's really, really strange in the terms that you're dealing with a cube root here and a square root there. So the idea is to get these bases the same. So a 4 and a 2. So let me show you what I mean by that. Let's say I have this 4 to the 1/3 power times 2 to the 1/2 power. Again, here are my bases right here, 4 and 2. If I could somehow get those to be the same number, since I am multiplying them, I would just have to add my exponents and I can get the answer. So the question is, how do I make 4 represent a 2? So I have to rewrite a 4 as a base of 2. So how about 2 squared to the 1/3 times 2 to the 1/2? Notice now that I'm working on a same base of 2 and a base of 2. So that gives me 2 to the, since I'm raising a power to a power here, that's 2 to the 2/3 times 2 to the 1/2. And now I have, my bases are the same. So if the bases are the same, I'm allowed to go 2 to the 2/3 plus 1/2 power, which of course is 2 to the 7/6 power. If you don't remember how to add fractions, you add those two fractions together to get 7/6 power, which is just the 6th root of 2 to the 7th, which is the 6th root of 2 to the 6th, times the 6th root of 2 to the 1st. So that gives me an answer of, since I have the 6th root of 2 to the 6th, the 6's go away, and that gives me an answer of 2 times the 6th root of 2, and that's the right answer. So all of this breaks down to 2 times the 6th root of 2. And then I did a U-try in class. So, okay, so here's what we got for the U-try. You can rewrite the square root of a times the cube root of a into a cube root of a all to the 1/2 power. Then break down the cube root into the 1/3. So you've got a times a to the 1/3 to the 1/2. When you raise a power to a power, remember you multiply them, so it's a to the 1/2 power. And then a to the 1/3 times 1/2 gives you the 1/6. Now notice your bases are the same. If your bases are the same, you add the exponents. So 1/2 plus 1/6 is 4/6. simplifying to 2/3, which gives you the answer of the cube root of a squared. Okay, then we went on to simplifying expressions using rational exponents. The first one here is, since we have a negative exponent, we're going to take that and take the reciprocal of this, so it's going to be y to the 2/3, all divided by 2x to the 1/3, all to the positive 3. Now, since I raise a power to a power here, 2/3 times 3 is just y to the 2nd, and then 2 to the 3rd is 8, and then x to the 1/3 is just x, and that's just the answer right there. That one's not so bad. Number 9, we have 9 to the 1/2 power, which is the same thing as the square root of 9, so that is equal to 3. We have x to the squared to the 1/2 power is x to the 1st. Y to the 1/3 to the 1/2 is the 1/6 power, all divided by x to the 1/3 to the 1/2 is x to the 1/6. You multiply them together, and then y to the 1/2. Now that gives me 3 times x to the 1 minus 1/6. So I'm going to say 6/6 minus 1/6 to simplify this right here. 6/6 and 1. I'm just rewriting that to subtract those two numbers. And then I'm going to have y to the 1/6 minus 1/2. 1/6 minus 1/2. Now that simplifies all the way down to 3 to the 6/6 minus 1/6 is 5/6. Y to the negative 1/3. When you simplify, when you add 1/6 minus 1/2, you get negative 1/3. So that is that's 3 to the, x here. 3x to the 5/6, all divided by y to the 1/3, and I think that's exactly how the book leaves it. Yep, sure is. And then last was a U-try. So don't get freaked out by the fact that you have these in here, right? Just consider, since they're all the same, you can consider those as just a variable. So really this question is asking you, do you know what to do with all of these exponents you have? Okay, let's see if you got the answer of 3x plus 1 to the 7/12. Here is how you do this. Okay, so we have 1/3, negative 1/2, and a negative 3/4 and an exponent. So notice I have the 1/3 plus the negative 1/2 because I'm multiplying right there these two top expressions, binomials, and then subtracting a negative 1/3 because I am dividing the last one. So 1/3, 1/2, and 3/4, I changed all to a common denominator of 12, so I can deal with it. So 1/3 into a common denominator of 12 is 4/12, 1/2 is 6/12, and 3/4 is 9/12. So 4 minus 6 is negative 2. Negative 2 plus 9 is a positive 7/12. So the answer is just 3x plus 1 all to the 7/12. All right, there you go.